So let's continue to talk about primes. One of the courses that I took as an undergraduate was History of Math. And it was one of my favorite classes. It's very interesting to look at how things developed over time, right? And look at these math concepts historically over thousands of years. And one of the things that stood out to me in that class is how much we talked about primes and how much we talked about how prime numbers really fascinated mathematicians for centuries, right? Mathematicians were really very interested and kind of mystified by primes for two main reasons. All right, so most of math is predictable, right? In math, we notice patterns. Patterns turn into formulas. Formulas give us nice, easy ways to do our mathematics. So with so much other things being predictable, primes are not predictable. So that day that we found all the primes between 1 and 100, one of the things that I asked you to do was to look at that chart and say, do we see any patterns in the chart, right, in our list of primes? And the answer to that was no. So one of the reasons that mathematicians are so mystified by this is that let's say this, prime numbers do not occur in any predictable pattern, right? Unlike so much else in math, all right? There's no predictable pattern, and there is no formula to generate, despite many attempts at a formula, right? There is no formula to generate all the prime numbers. Okay, but what we're going to do right now, so let me give you a minute to copy this into your notes because I'm assuming you're taking notes along with me. But what we're going to look at in this section is the best attempts at a formula for primes. Okay, these are good attempts, but they're flawed attempts. And we'll talk about, what makes these formulas imperfect, right? So what's positive about them, but why are they not perfect formulas for the task at hand, which is to generate all the primes? And the most popular method for finding larger and larger primes, because mathematicians are still fascinated with primes, and we are still discovering larger and larger primes. If they do find another prime number, another larger prime number than the one that's currently known, it does get like a little 5-minute blurb on the 6 o'clock news. All right, so it's that important. But anyway, the best attempt here is something known as a Mersenne prime. Okay, and what a Mersenne prime is, it is anything of the form, maybe I should be using a text box here, 2 to the p minus 1. Okay, so p has to be prime. Okay, so p can't just be any number. P must be prime. Okay, so p could equal 2 or 3 or 5 or 7, not 9, 11, 13, 17, 19, 23, 29, any primes. Okay, and so as we go through and start looking at the first few Mersenne primes, okay, so let's do blue here. Okay, so the first Mersenne prime would be 2 squared minus 1. Right, well, that would be 3, and 3 is prime. Okay, then I would have 2 cubed minus 1. Right, which is 8 minus 1, which is 7. 7 is in fact prime, but notice I skipped 5. Okay, so there's problem number 1. I'm not generating all the primes. Okay, so maybe I'll come over here and we'll note the problems with the formula. Okay, so problem number 1, not, all right, the formula, okay, this formula doesn't generate all the primes. Okay, so it's giving me prime numbers so far, but not all of them, right? I just skipped 5. Then when I do 2 to the 5th, so that's 32 minus 1, that's 31. And so obviously I skipped a whole bunch of primes in between 7 and 31. Okay, but if I kept going, and so 2 to the 7th, I don't want to do too many with you in class because one of the things that you have to do on your homework is you have to give, I think it was 3 examples of Mersenne primes that weren't given in the notes. All right, so I don't want to do too many of them in the notes, but let me point out that if you attempted to use this value of P, right, which the formula says a Mersenne prime, or a Mersenne number, I should say, is a number which is 2 raised to some prime. So when I do this, and I get 2047, I'm sure it doesn't jump right out at you, but this is actually not prime. Okay, so the other problem with the formula, it's not giving me all the primes, and then sometimes this formula fails to find me a prime at all. All right, so this is a failure here. This is not a prime. Okay, so when I'm over here saying what are the problems, the problem is doesn't generate all the primes, and problem number 2, not all numbers in this form are in fact prime. Okay, so for your collected 4, you have to find 3 more Mersenne primes. And you might say, well, you know, how do I know if I get this really huge number, how do I know if it's prime? Okay, and you could do what you did in the last video where you take the square root of the number and you test all prime divisors up to the square root of the number. That would still be a lot of work, especially when you get to really large numbers that would be generated by values of P like 23 and 29. So I don't want you to do all that work. All right, I want you to go to this website. So I'll have this link on the collected homework assignment. And I want you to go to this website and I want you to look at the number that you chose for P, and I want you to see if it is in fact prime. Okay, but talking a little bit more about the largest known primes that we've discovered. And some facts about prime numbers and Mersenne primes is that the largest known prime is a Mersenne prime, and in fact 9 out of the 10 largest known primes are Mersenne primes. Right? Because this is a nice efficient way to get potential numbers that might be prime. All right, and then a computer algorithm has to be used to determine if these absolutely enormous numbers do in fact have divisors or don't have divisors. Because this number, which was discovered, this is the largest known prime as of 2018, and this number contains, I have to find it here, over 24 million digits. And it's hard for us to even comprehend that. So let me give you a little perspective here. If I typed that out in 10-point font, so if I took this number, this Mersenne prime, and I typed it out in 10-point font, it would be 57 miles long. Okay, so from Geneseo, that's probably from like Geneseo to Buffalo, all right? Or if you lived about an hour and 20 minutes from campus, that's probably about 57 miles. So try to envision this number typed out in 10-point font, running all the way down the thruway, right, for 57 miles. All right, so that gives you some perspective on, you know, how large that number actually is. But what's been kind of interesting to me, I've been teaching this class since 2007. So every year before I teach this lecture, I have to do a Google search and make sure I haven't missed any new primes being discovered. And if I look back at my notes over the years, and I've made sure to keep the same note page over the years. So I started in 2007, and right before I started, there had been 2 new Mersenne primes discovered in 2005, 1 discovered in 2006, right? The next year after I had first started teaching this, there were actually 2 Mersenne primes discovered in the year 2008. Then we had a dry spell, all right? No new primes were discovered between 2008 and 2013. All right, then there was another one in 2016, another one in 2017, and then this latest in 2018. All right, so nothing for about the past year and a half. So if we were in class, I would ask you what your instincts say as far as whether or not the number of primes would be infinite or finite. Like, do you think that at some point we're going to find the very largest prime number that there is and then be done? Or do you think that there would be an infinite number of primes? All right, because some people have this idea that, you know, our numbers, they go on for a really long time, right? Dot, 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 dot. We go on for a really long time. And then eventually we get to the sideways 8 thing and then we're done. Right? Remember, infinity is not a number. Infinity is a concept. Infinity means our numbers go on and on and on forever, right? So would it make sense that there would be no largest prime, right? That I could keep on trying to find a larger and larger prime and always be successful because there's always going to be another prime, right? That I'm never going to actually get to the largest there is and then be done. Okay, and it is true that there is an infinite number of primes, and I'm going to prove that to you in the next video segment. So a couple years on the test, so at this point tests are optional for you guys, but many years I would have a test question that where I would say, tell me 2 facts about Mersenne primes. All right, and one of those facts that stuck in people's mind the most would always be this. Right, that the largest known Mersenne prime is 57 miles long. Okay, other facts then that I was hoping people would tell me is I was hoping people would tell me the format of a Mersenne prime, right, that they're numbers of this form. Okay, but this would always stick in people's minds. So anyway, I had said I had 2 attempts, 2 best attempts at a formula. So the other attempt is this formula. I'll do colon. All right. If I were to take a number, and so this is true for n can be anything. All right. So n can be any natural number starting with 1, right? It doesn't have to be prime like, you know, p had to be prime. And if I square n, subtract n, and add 41, often I will get a prime number. Okay, but I have exactly the same problems that I had in the last example, where not all numbers of this form are prime, and I'm going to skip a bunch of primes. So notice if I start with n equaling 1, right, 1 squared minus 1 plus 41, that would generate 41. All right, then if n is 2, if I do 2 squared, 4 minus 2, so that's 2, plus 41, I get 43. So notice I skipped an awful lot of primes between 2 and 41. Okay, so I'm not generating all the primes, But this formula actually does work quite well. It will, as far as giving you numbers that are prime, okay, so that was one of the problems with Mersenne primes, is we could follow the rule of the formula and yet get a number that wasn't prime. We could get a number that was composite, even though we followed the rule of the formula. And this, so let's see, if n is 3, I get 47, and so on and so on. But let me give you this hint for your homework. This will work up until, so the first time that it fails is when we get to n equaling 41. Okay, when n equals 41, then I do not get a prime, because I would have 41 squared minus 41 plus 41. So I would get 41 squared. Well, 41 squared would have a factor of 41. All right, so on your homework, when I tell you to find 3 more prime numbers using this formula, you're safe as long as you don't pick an n greater than 41. Okay, but you can use any n, right? So any number 4 through 40, right? So just plug that in to the formula. You're certain to get a prime number if you do that, and that'll be points on the collected homework.